Dear students, hi everyone. This video I am going to explain balancing the equation, that is in class 11th. This is a very important chapter, balancing the equation of redox reaction. So in redox reaction, how to balancing the equation. So two methods are there. One is oxidation number, another one is ion electron method or off reaction method. So both the methods are very important. So based on the method, number of problems will be asked in your examination. So listen carefully. So two methods are there. In this video I am going to explain the first method, that is oxidation number method. So both are based on the same principle in oxidation reduction reaction. The total number of electrons donated by the reducing agent is equal to the total number of electrons gained by the oxidizing agent. What is redox reaction? Redox reaction means both oxidation and reduction takes place in same chemical reaction. What is oxidizing agent means? It acts as a gaining of electron. It acts as a electron gaining. So what is electron? That is reducing agent. It acts as a electron donor. Oxidizing agent electron act as a electron acceptor. Reducing agent act as an electron donor. So based on the method, so how many electrons the reducing agent, so donate how many electrons, that number of electrons should be accepted by the oxidizing agent in any redox reaction. So based on the principle, so we are going to learn about the two method. One is oxidation number method, another one is ion electron method. The first one, oxidation number method. So in this method, number of electron lost or gained in the reaction is calculated from the oxidation number of elements before and after the reaction. So how many electron lost or how many electron gained, how we can find out using the find out the oxidation number of element in before and after the reaction. So one example is given. So let us consider the oxidation of ferrous sulfate by potassium permanganate. What is the formula for ferrous sulfate? FeSO4. It should be here. Ferrous sulfate is oxidized by potassium permanganate in acid medium. This is the medium. So here acid medium, the acid is taken as sulfuric acid. So in the presence of acid medium, when both are reacting together, ferrous sulfate and potassium permanganate, here ferrous sulfate oxidation takes place by potassium permanganate. So leads to the formation of ferric sulfate plus manganese sulfate plus potassium sulfate plus water. So this is overall redox reactions. So now you only going to calculate. So overall it is a redox reaction. It is given as redox reaction, but we don't know which metal is oxidized, which metal is reduced. So first we should calculate the oxidation and reduction of the element in both reactant side and product side. It should be followed by different step. So step 1 is nothing but using oxidation number concept, identify the reactants which undergo oxidation and reduction. So we know very well about to find out the oxidation number. So based on the oxidation number concept, first we find out the reactants. In reactant side, which element undergo oxidation and reduction. So next here one reaction that is given again, ferrous sulfate, potassium permanganate. So how we can find out for each element? First we should find out the oxidation number. Consider here only potassium, that is in ferrous sulfate we should consider the element iron and manganese. So first see how to find out the ferrous sulfate. In ferrous sulfate, how to find out the ion oxidation number. So we know about, very well know about SO4. SO4 is a group of element. What is that oxidation number for SO4? That is 2 minus. So X, we don't know X. So X minus 2 is equal to 0. X is equal to what? Plus 2. So here ferrous ion oxidation number is plus 2. X is nothing but what? Ion. Here ion oxidation number is plus 2. So what is that? What in that product side? Product side ferric sulfate. How to find the ferric sulfate here? Again sulfate oxidation number minus 2. Here how many sulfur atoms? So 3. So 3 into 2 minus 6. Here ion we don't know means that is X. Here 2 X are there. So 2x minus 6 is equal to 0. So 2x is equal to 6, x is equal to plus 3. So in the product side, what is that? Oxidation number of ion plus 3. So plus 2 to plus 3, oxidation number increases. So here in this reaction, ion element is oxidized from plus 2 to plus 3. That is oxidation. So next we have to consider manganese. So manganese in product side, where manganese there? In potassium permanganate. In potassium permanganate, how we can find out manganese oxidation number? We know very well about potassium oxidation number is plus 1. Oxygen, for one oxygen atom minus 2, here 4 oxygen atoms are there. So 4 into minus 2 minus 8. So overall, that is, we don't know x, so we have to got like this down. So x minus 8 plus 1 means minus 7 is equal to 0. So x is equal to plus 7. So what is that oxidation number? X is nothing but manganese. In potassium permanganate, what is the oxidation number for manganese? Plus 7. Next one. So we in the product side, the reactant side plus 7. What about the product side manganese? We can find out. So we don't know about manganese means manganese should be x. SO4 minus 2, that is equal to 0. So x is equal to plus 2. So in the product side, what is the oxidation number for manganese? Plus 2. In the product's reactant side, plus 7 to plus 2. So oxidation number decreases. So it should be reduction. So in this reaction, manganese as the element is reduced from plus 7 into plus 2. So now we found which element is oxidized and which element is reduced. We have to consider other also. Potassium, that is all as a neutral, that should be, there is no oxidation, there is no reduction takes place, remaining other elements. Okay, just here, one element is oxidized and one element is reduced. That is nothing but iron is oxidized and manganese reduced. This is oxidation, this is reduction. So first step, what is the first step is given? Using oxidation number concept, identify the reactants which undergo oxidation and reduction. The reactant side, now we found which one is oxidized. Iron is oxidized, oxidation takes place, manganese reduction takes place. What is the next step? The oxidation number of manganese in KMnO4 changes from plus 7 to plus 2 by gaining 5 electron. So what is the meaning for that? So manganese, in the reactant side plus 7, now have to be in the product side, it changed into Mn2 plus. So electron, that is, it is gaining electron or losing of electron. When manganese gain 5 electron means it will be converted into Mn2 plus, isn't it? So here manganese gain how many electrons? 5 electrons. So when manganese gain 5 electrons, leads to the formation. Now it has been changed into Mn2 plus. What is that meaning further? Gaining of electron is nothing but reduction. So here manganese, in this overall redox reaction, the manganese reduction takes place. What is that for iron? Oxidation of number of iron in FeSO4 changes from, so Fe2 plus into Fe3 plus. What is that? Iron here, one positive charge increased. What is the meaning for that? It will lose one electron. So when iron lose one electron, it will be changed into Fe3 plus. It is a losing of electron is nothing but oxidation. Gaining of electron, reduction. Losing of electron, oxidation. Is it clear up to that step? Is it clear everyone? First we should find in that reaction, in the reactant side, which element is oxidized, which element is reduced. So using the oxidation number calculation, we found in the reactant side manganese reduction takes place by the gaining of 5 electron. Iron, in iron sulfate, ferrous sulfate, oxidation takes place by the losing of 1 electron. So what is the step 2? Since the total number of electrons lost is equal to the total number of electrons gained, equate the number of electron by cross multiplication of the respective formula with suitable integers on reactant side as below. So first, next step is nothing but, what about the principle? In any redox reaction, the losing of electron, it should be equal to the gaining of electron. So we have to equate the number in both the side. So first and also one thing you should one thing you should listen now. So in this case, in the reactant side, you have to see what is the number of moles of iron. What is the number of moles of iron? 1. But in the product side, what is the number of moles of iron? 2. Here, the reactant side, what is the number of moles of manganese? 1. Here also 1. We should balancing that iron also, isn't it? So that how many electron lost, how many electron gained. But first in the reactant side, we should balancing iron with the losing of electron or gaining of electron. So formula is writing again, FeSO4, KMnO2H2SO4, they leads to the formation of the product. Here you have to consider, now iron oxidation takes place by the losing of how many electron? 1 electron. Manganese reduction takes place by the gaining of how many electron? 5 electrons. Why we should multiply the number, both the number of losing of electron, gaining of electron? Why here it should be multiplied with the number 2? See here to balancing iron first. To balancing not only iron, the whole reactant side, first we are going to balancing by the cross multiplication of the electron and equate the electron also. Yeah, see here. So here iron number for us, iron number is 2, but in the reactant side only 1. So first we have to multiply the number of losing electron or number of gaining electron by the iron and manganese with the number 2. So iron oxidation takes place by the losing of 1 electron, so 1 electron into 2. Manganese reduction takes place by the gaining of 5 electrons, so 5 electron into 2, so overall 10. After that we have to cross multiply that number. So 10 into ferrous sulfate, 2 into potassium permanganate, and we have to get the equation like this. 10 FeSO4 plus 2 KMnO4 plus H2SO4 gives Fe2SO4 thrice plus MnSO4 plus K2SO4 plus H2O. So the reactant side we balance the equation both iron and manganese. What about the product side? So what is the next step 3? Balance the reactant, product, oxidized and reduced. So now balance the reactant and product. So which one is oxidized, which one is reduced? That element should be present in the equal number in both reactant side and product side. How to balancing now? So you see here, so in the reactant side, how many number of iron atoms are there? 10. But in the product side only 2. So this side also we need number 10. How we can change it? So in before ferric sulfate we have to put a number 5. Now the iron oxidation number of moles have to be 5 into 2, that is 10. So in the reactant side also 10, in the product side also 10. What about potassium permanganate, that is in manganese? You see here, potassium, the reactant side 2, product side also 2. But manganese, the reactant side 1, product side 1, reactant side 2, product side only 1. So we should balancing the product side manganese also. So before manganese, we have to put a number 2. So now we balanced in both reactant and product side the element oxidized and reduced. So we have to balance now both the side iron and manganese. So what about the next element? Now we are going to balancing the other elements. So balance the other elements except hydrogen and oxygen. So leave the sulfuric acid and water. So now we are going to balancing the other element, that is sulfur. Potassium also balanced, all the metals all balanced. Now we have to consider the sulfur. So how we can balance the sulfur now? First count the sulfur in the reactant side. You leave sulfuric acid and water. Just here, how many sulfur atoms? Only 10. But in the product side, how many sulfur atoms? Here, already 3. 5 into 3, 15. So here, 15 plus 2 plus 1. So overall 15 to 17 and 18 sulfur atom in the reactant side. But only 10 in the reactant side only and 18 in the product side. So reactant side also we need number 18. What is the meaning for balancing chemical equation? Both the side atom number should be present in equal, isn't it? So on the reactant side only 10, but product side 18. So we need in the reactant side also 18. So how we can balancing that is sulfur? So only another group also is there, that sulfuric acid, that also having sulfur. So before sulfuric acid we have to put a number 8 to balancing sulfur atom. Now we have to check in the reactant side 10 and 8, 18. So in the reactant side also 18, here also 18. Sulfur also balanced in both the sides. What about hydrogen and oxygen? First we have to balance the hydrogen, automatically oxygen will be balanced. So now we have to check hydrogen. In the reactant side, how many hydrogen atom? 8 into 2, 16. But in the product side, what about the hydrogen atom? Only 2. So this side also we need number, reactant side 16 hydrogen atom, product side 2 hydrogen atoms. So therefore multiply the water molecule in the product side by 8. 8 H2O we got. The reactant side 8, product side also we need number 8. So we have to multiply the water molecule with 8. Now both the side water also equal, 8 into 2, 16. Here also 8 into 2, 16. Now all the oxygen atom is now automatically balanced. This is the overall. Now we are going to check all the oxygen also have to be balanced. How we can check now? Here how many oxygen atoms? 4 into 10, 40. Here how many oxygen atom? So 4 into 10, 40. Here how many oxygen atom? 4 into 2, 8. Here how many oxygen atom? 4 into 8, 32. So 32 plus 8, 40, 40 plus 80, overall 80 in the reactant side. What about the product side? How many oxygen? Here 4, 4 into 3, 12, 12 into 5, 12 into 5, 60. Here 4 into 2, 8. Here 4. Here 8. So 8 plus 4, 12 plus 8, 10. So overall, so 8 plus 4, 12, 12 plus 8, 20. So overall 80. So the reactant side and the product side oxygen number is 80, isn't it? So now all the elements in both the side, all the atoms in both the reactant side and product side are balanced. So this is the overall balanced chemical redox chemical reaction using the oxidation number method. So total 5 steps are there. First step, to find the oxidation number. Based on the oxidation number in the reactant side, which metal is oxidized and which metal is reduced. So how many metals, which metal is reduced? So reduction takes place means how many electron it gain. Oxidation takes place means how many electron it loses. So that only first step we found. What is the step 2? So to balancing the number of electron, because the losing of electron, gaining of electron, it always should be equal in the redox reaction. So based on the concept, we have to equate the number of electrons. So we have to cross multiply the number of electron. Before that, we should check the ion. In the reactant side only 1 ion, but in the product side 2. So first we have to, no worry about the manganese. Manganese both the side are equal, but the product side and reactant side some variation. Here 1, here 2. So first the number of electrons should be multiplied with the number 2 to balance the ion. Then the cross multiplication takes place to balance the number of electron. What is the next third step? So balance both reactant and product of oxidized and reduced element. So overall oxidized reduced element balancing over. So next to consider other elements. So other than hydrogen, oxygen, we have to consider what about any elements, other elements are there, that is sulfur. So next step, we balance the sulfur atoms in both the side. The final, what is that? To balance hydrogen, automatically oxygen is balanced. So this is the balanced redox reaction of ferrous sulfate and potassium permanganate in presence of acid medium. So in the next video, I will be explain about the same balancing redox reaction in second method, ion electron method. So hope you all understand now. Thank you, students.